Yeah, question 17 in Unit review. So I think, Sam, you had a question about how to do this, and it looks like you've already figured it out through your homework. Looks like your review, you already had 100%, and you did a great job on your exam as well. But I'll go ahead and talk about question 17 anyway, even though you obviously figured some of this out. Uh, So again, in question 17, it does say decide whether you can use normal distribution to approximate the binomial distribution. So remember, with our calculator, binomial distribution would be pretty time consuming. You'd have to probably build some type of spreadsheet tool to make that work a little bit more efficiently. But as is, in some situations, we can use something rather more simple, which is what's called a normal distribution to approximate the binomial distribution. So our question, going to have a survey of adults found that 7% say their favorite sport is auto racing. After the movie F1, that may change a little bit. F1, we really enjoyed it this summer. So you randomly selected 300 students and you asked them to name their favorite sport, complete parts A through D. So the question is, can we use a normal distribution to figure this out? And so some of the things that we have to make sure we know are first, to do the normal distribution, we have to pass these two tests. The sample size times the number of successes, the percent of success, has to be greater or equal to 5. And the sample size times the percent of failures has to be greater or equal to 5. Also, we're going to use our calculator on this. We're not going to use these scores. But in our calculator, we're going to determine the mean by using the sample size times the number of or percentage of successes. And the standard deviation is going to be, again, the square root of the sample size times the percent of successes times the percent of failures. So, as we know that in this example here, that the sample size was 300, and the chance of people saying that their favorite sport is auto racing was 7%. So if we multiply 300, so 300, so 300 times this 0.05, that's going to be then this 15. So that is going to be greater than equal to 5. Then if we do the 300 times then again, Q is going to be the flip side of that, which would be like 93%, 0.93. And of course, 93% of 300 is going to be way bigger than 5. So 300 times 0.93 would be then, as we were saying, see if I can get this thing to kind of straight back out again. 279. So this means, as you said, yes, we can use the approximation to do the binomial distribution. So from there, first question is find the probability that the number of people who say auto racing is their favorite sport is at most 26. Now, to use the normal distribution, notice that the mean is here at 15. And it says at most 26, but to do the normal approximation, we have to create a continuity correction. So at most 26 means we want to include the 26. To include the 26 means our correction has to be to the right of that. So we need like this 26.5. Again, my graph is not accurate. It's a rough sketch there. So at most 20, what we want to do then is at most 26 means we can't go past 26.5. So we want to find the area under the curve from over here to there. So to find the area of the curve, we have our normal curve stuff on our calculator. So that's under distribution. So I do second distribution. Number two does the normal. So there is not a left bound, so we can use a negative 10,000 there. Our right bound is 26.5. Now, to do the mean, we can do this 300 times 0.07. To do the standard deviation, we can do the square root of the sample size of 300 times the probability of successes, which was 7%, times the probability of them saying no, would be 93%. So if we enter there, we end up within 0.8934. So that's what I'm coming up with there is 0.8934. So there may be some rounding that we're allowed to do on the calculator there. So that's what I came up with is 0.8934. So check, sure. So, because I do that all the time. So left bound 26.5 sounds good. So 7%, 300, that looks good. And 300 times 0.07 times 0.93, that all looks good. So that's what I'm coming up with. Is that 0.8934. So there may be some acceptable range as far as rounding goes there on that. So if we kind of like on the calculator, if I did say the standard deviation, if I did that outside the calculator, um, let's see here. So if I did like square root, uh, yeah, times 107 times 0.93. I actually use that as my standard deviation, which actually gives it more power to actually know what the standard deviation was. Because you remember, if you go out past two standard deviations from the mean, then you're getting into what's considered a not it's kind of more of an unusual event. So getting a clearer picture of that standard deviation would be more helpful. We kind of cut corners here and just go straight to the answer. So if I go back in here and change this to 4 point, 3, and then do it. I'm still getting 0.8933. So I'm not sure why we're off by a few test points there. If we move on down to do one more, find the probability that the number of people who are, say, all racing is more than 30. So again, more than 30, again, your mean is 15. More than 30 is going to be out here. More than 30 means you cannot include 30. So your continuity correction means you have to be to the right of that. You have to be like 30.5 and to the right of that. So if we use our normal curve, so now we do have a left bound of 30 point, I'm sorry, yep, 30.5. There is not an upper bound, so I usually use 10,000 there. And then I don't think any of this other stuff changes. So we hit enter. We do get this 0.0158. So we do get that basically the same answer as you, 0.0158. So that is the correct strategy to do these problems. So you're probably on the right track. So whatever you're doing there, keep it up. So I'll stop there. If you have any more questions, feel free to reach out to me.